Good day, everyone. I am Luis Adrian Toraya, and today I'll be discussing the topic of my report Collaborative Science Learning in Overcrowded Classrooms, exploring peer teaching, group experiments, and structured teamwork as constructivist strategies to manage large class sizes while ensuring equitable participation. Now, first, let us understand constructivism. So, constructivism is a philosophy of education, and um, there are two most influential proponents of constructivism. We have Jean Piaget and Lev Vygotsky. So why did I choose constructivism as my philosophy of education? I chose constructivism as my philosophy because as a science educator, one of my hopes for my students is for them to become curious and independent learners. So what really is constructivism? So constructivism, here are its key principles. Learning is an active, not passive. Students construct knowledge based on prior knowledge and new experiences. Learning is more meaningful when connected to real life situations. Students learn through exploration, inquiry, and problem solving. Collaboration and discussion with others enhance understanding. Mistakes are viewed as opportunities for learning. And lastly, reflection helps students deepen their own understanding. So here are a statement emphasized by Lev Vygotsky in 1972. So constructivism is a philosophy that views learning as an active process in which learners construct knowledge by connecting new experiences with what they already know. Learning becomes more meaningful when students learn alongside others in exchanging ideas and receiving guidance that helps them achieve what they could not accomplish on their own. Now,
So,
according to
in
Vygotsky, constructivism is a philosophy that views learning as an active process. This means that students do not simply receive information from the teacher. Instead, they actively construct knowledge by connecting new experiences with what they already know. Every learner enters the classroom with prior knowledge, and new learning becomes meaningful when it builds on those existing ideas. Vygotsky also emphasized that learning is a social process. Students learn more effectively when they interact with others, whether through discussions, group work, or collaborative activities. By exchanging ideas, asking questions, and sharing different perspectives, students deepen their understanding of the lesson. Another important idea from Vygotsky is that learners can accomplish more with guidance than they can on their own. Through the support of their teachers or more knowledgeable peers, students are able to perform tasks that would otherwise be too difficult independently. This concept is known as the zone of proximal development or the ZPD. Now, as educator, this reminds us that our role is not only to teach content but also to facilitate meaningful interactions, encourage collaboration, and provide appropriate guidance so that students can gradually
and the
become
principal.
independent learners. Now that we understand the principles of constructivism, let us see how they are applied in science teaching. So, applying constructivist principles in science teaching. Constructivism is applied in science teaching by actively engaging students in investigating, experimenting, discussing ideas, and solving problems instead of relying solely on teacher led lectures. In this approach, the teacher serves as a facilitator who guides learners in constructing their own understanding through meaningful experiences and collaboration. That is according to Piaget in 1972. This is particularly relevant in many Philippine science classrooms where teachers often um, handle large and diverse classes with limited laboratory resources. Despite these constraints, constructivist practices can still be implemented through peer teaching, group experiments, and structured teamwork, allowing students to learn from one another while making the most of available resources. Constructivism emphasizes that students learn science best when they are actively involved in the learning process. Instead of relying only on lectures, students investigate scientific questions, conduct experiments, discuss their observations, and solve real world problems. Through these experiences, they construct their own understanding of scientific concepts. In this approach, the teacher's role changes from being the primary source of knowledge to becoming a facilitator. Rather than simply giving answers, the teacher asks students guiding questions, provide appropriate learning experiences, and encourages students to think critically and arrive at their own conclusions. This reflects also in Jean Piaget's idea that learners build knowledge through active experiences. This approach is especially relevant in the Philippine setting because many of our science classrooms have large class sizes and limited laboratory equipment. However, these challenges should not prevent us from implementing constructivist teaching. Even with limited resources, teachers can organize group investigations, peer teaching, collaborative problem solving, and simple hands on activities using locally available materials. For example, instead of demonstrating an experiment while students only observe, the teacher can divide the class into groups and let each group perform the investigation, discuss their findings, and present their conclusions. In this way, students learn not only from the teacher but also from one another. Ultimately, constructivism teaches us that meaningful science learning happens when students actively explore, collaborate, and connect scientific concepts to real life experiences. This is the kind of learning environment that we should strive to create as science educators. Although constructivism offers many benefits, implementing it in real classrooms is not always easy. In the next slide, let us discuss some of the challenges teachers may face when applying constructivist principles. So, what are the challenges in constructivism? So, what makes constructivism challenging to implement? In the Philippine educational system, implementing constructivist strategies in science classrooms can be challenging due to large class sizes, diverse learner needs, and limited instructional resources. Many teachers have to manage classes with a high student to teacher ratio, making it difficult to facilitate group activities, monitor experiments, and provide individualized support. Limited laboratory equipment and science facilities may also restrict opportunities for hands on and inquiry based learning. In addition, teachers often need to balance learner centered activities with curriculum requirements, classroom management, and assessment responsibilities, making the consistent implementation of constructivist practices more demanding. That is according to Lee and Nguyen in 2022 and Department of Education in 2023. One major challenge is the large class size. Many public school teachers handle 40 to 60 plus students in a single class. Because of this, it becomes difficult to monitor group activities, provide individual guidance, and ensure that every learner actively participates. Another challenge is the limited availability of instructional resources. Some schools have insufficient laboratory equipment, science materials, or learning facilities. Since constructivism emphasizes hands on and inquiry based learning, these limitations can make it more difficult to conduct experiments and other interactive activities. Teachers also need to address the diverse learning needs of their students. Every learner has different abilities, backgrounds, and learning styles. Facilitating meaningful discussions and providing appropriate support for all students require careful planning and effective classroom management. In addition, teachers must balance constructivist teaching with curriculum requirements, time constraints, and assessment responsibilities. Um, Designing engaging activities, facilitating discussions, and assessing students' learning all require additional preparation and effort. Despite these challenges, constructivism is still possible to implement with creativity, proper planning, collaboration, and the effective use of available resources. Teachers can create meaningful learning experiences even in resource limited classrooms. The important thing is not having the most advanced facilities, but creating opportunities for students to actively think, explore, collaborate, and construct their own understanding. Now that we have discussed the challenges, the next question is how can we make constructivism work in our classrooms despite these limitations? Let's look at some practical strategies. Now, how can we make constructivism work in the classroom? So, here are the several practical solutions that can help teachers overcome these challenges. So, first, we have implement structured cooperative learning. So, teachers should assign specific roles such as leader, recorder, presenter, and materials manager during group activities. Clear roles promote accountability, encourage equal participation, and reduce the tendency of some students to dominate group work, according to Lee and Nguyen in 2002 and Gillis in 2016. Integrate peer teaching also. So, peer teaching allows students to explain scientific concepts to one another, while the teacher facilitates discussion and addresses misconceptions. So, this strategy improves engagement, confidence, and conceptual understanding, particularly in large classes. So, according to Lee and Nguyen in 2002 and Vygotsky in 1978. For number three, organize smaller learning groups. So, whenever possible, students should work in pairs or small groups of three to maximize interaction and participation. Smaller groups encourage more meaningful discussions and reduce passive learning, according to Jiang and Blue in 2023. For number four, combine group work with individual assessment. So teachers can use short quizzes, reflection journals, or exit tickets alongside group activities to ensure that every students remain accountable for their own learning, according to Chen et al. In 2022. For number five, maximize available resources. Limited laboratory equipment can be addressed by using rotating laboratory stations, low cost materials, or virtual laboratory simulations. These alternatives allow students to engage in inquiry based learning despite resource limitations. By Ling and Nguyen in 2022. For number six, establish clear classroom routines, providing clear instructions, assigning responsibilities, and setting time limits before collaborative activities helps maintain order and improves classroom management in overcrowded science classes. That is according to Lee and Lian in 2022. Number seven, provide continuous teacher professional development. Schools should offer regular training on constructivist learning teaching strategies, cooperative learning, and classroom management to help teachers effectively implement learner centered instruction in large classes. That is according to Chen et al. In 2022. And lastly, number eight, strengthen school support. School administrators can support constructivist teaching by improving access to instructional resources, encouraging collaborative planning among teachers, and promoting policies that foster active and inclusive learning environments. So that is according to Department of Education in 2023. So why does constructivism matter in science education? So for the conclusion, effective science teaching depends not only on classroom conditions, but also on how learning experiences are designed. When students are given opportunities to investigate scientific concepts, exchange ideas, and learn collaboratively, develop a deeper sense of understanding of science while strengthening essential skills such as critical thinking, communication, collaboration, and problem solving. Now, moving forward, science teachers are encouraged to adapt constructivist strategies to their learners' needs and classroom context, while schools should continue supporting um, teachers through professional development and adequate instructional resources. These recommendations are consistent with the Department of Education's Matatag curriculum, which promotes learner centered, inquiry based instruction and allows schools to implement curriculum in ways that respond to their specific context and capacities. That is according to Department of Education in 2024. So, in conclusion, no, constructivism reminds us that learning is not simply about transferring knowledge from the teacher to the student. Instead, it is a process in which learners actively build understanding through their own experiences, inquiry, reflection, and collaboration with others. As an educator, our role is not only to provide information, but also to create meaningful learning opportunities that encourage students to ask questions, think critically, solve problems, and connect what they learn to real life situations. As a science educator, also, one of my hopes is to inspire students to become really curious individuals and independent learners as well, who explore scientific concepts through investigation and discovery rather than memorization. And by applying the principles of constructivism, we can help develop not only students' knowledge, but also the skills and attitudes they need to become lifelong learners. So I would like to end my presentation with a quote from Lev Vygotsky. Through others, we become ourselves. This quote reminds us that learning is not something we do in isolation. We grow through our interactions with teachers, classmates, family, and our community. As educators, we have the opportunity to create learning environments where students learn not only from us, but also from one another. By encouraging collaboration, discussion, and shared experiences, we help students develop both academically and personally. And that ends my report. Thank you very much and have a great day.